Good morning, everybody. Welcome to the first SCCER Mobility Seminar Series that is part of our Young Talent Development Program that we started new this semester. I would like to welcome the audience that is here live in this room and also welcome the audience that is participating virtually. The motivation behind the seminar series is one, to give young scientists another platform for presenting their SCCER mobility related research projects, and also to bring together the different research groups and the different locations. Today, our first speaker, I would like to welcome Dimitri Demin. He's a research scientist at Bern University of Applied Sciences in the Density program, and he will be presenting today modeling methods for assessing urban mobility behavior in the context of urban densification. Before I give the word to him, I would like to just explain how this webinar is going to proceed. So we're going to have a presentation of about 15 to 30 minutes, depending on what Dimitri prepared, and then we will have about 10 to 15 minutes questions. The live audience, I'll give the word to them first so that they can ask their questions here, and then I will take questions that you can type in the chat for the people that are watching or streaming the talk. So thank you very much, and now I would like to give the word to Dimitri.
Thank you very much. It's a great honor to be here. So the title of my presentation today is Computational Modeling Methods of Urban Mobility in the Smart City Context. As you know, cities are often referred one of the greatest inventions of mankind, and their urban habitats behavior is majorly influenced by population density and mobility. And if you look back, if we had just renewable energies, so we clearly see that the city was dependent on this sort of energy, and their mobility and people movement was also connected to that. The good supply was basically connected to the source of this energy. So we can still see the impact of this logistics still today. And if we move to today's environment, we know that by 2035, Switzerland is expecting 10 million of inhabitants, and 17% of that amount will be populated in the city. Already in our city are consuming approximately half of energy, and that major part goes to the mobility, where each urban object like buildings or infrastructure are dependent on that. So some numbers from the statistic are showing the evidence of some negative impact of population growth and the growing need of the mobility. This is also correlated to the cost load effects and growing emissions. So if you can see that 72% of private motorized vehicles are responsible for their major damage. So despite their implication on different scales, if you look closer, that we see that the small scale, like some measurements, or large scale statistics, providing us surprisingly little evidence about the correlation, the interaction between mobility and urban design. The reason is that the city is very complex and dependent on many criteria. And this complexity is emerging until now and basically going on since the invention of the motor vehicle and using fossil fuels. Today we're forcing problem of growing emission in their mobility consume, and within comes that the spatial constraints and considerations how we build buildings, put buildings in an urban environment resident for the future, and this impact both of their urban mobility and design system development. Learning should learn more of interaction of each other, but this is kind of complex, and we are lacking on communication between those stakeholders, which are on mobility system planning and urban space planning. What is the evidence is that we're working on different time scales in different timelines. And our major influence or our major aim is to provide a new framework to change the mindset between those two different parts of city planners and provide tools which are not developed yet. So basic on their ongoing research of SCCER, our density team, which is located on the Bern University of Applied Sciences, develops methods to process computational mobility demand models in this particular context. So our research based on our partners from ETH Zurich, from Institute of Environment Engineering. So we are glad to be part of ongoing research by Stefanie Hellweg and Andreas Frömmelt. In order to bring this new paradigm into the design of city, which is dependent on these two factors, mobility and the urban design itself, we need to look on different types of data. The first type of data is spatial data, georeferencing data. As you know, geolocated information systems. So we see building clusters as our entity with certain limitations. And as I said before, the city is too complex. This is why we're dividing the city into districts or areas defined on some mobility systems. And we are looking what kind of efficiency we could provide in this context. One of the examples of this I will show now is an approach which is represented by one of the major projects of in our group, which we are doing with partnership with Electro bus manufacturer HESS. And this cooperation has approached us to provide an innovative cockpit, a bunch of tools which combine the mobility and the GIS data with their aim to define urban qualities based on data, on the GIS data and on statistical data, and to provide an evidence how we use mobility and how we account the reduction of carbon dioxide. In particular, through the usage of electric bus systems. So the result is we came up with the Electro Mobility Information Platform, which we called e-MIP. e-MIP stays for Electro Mobility Information Planning Cockpit. And we're using this tool as a strategic roadmap that supports communication between official stakeholders and HESS. So the cockpit provides a selection of tools which interactively work with each other and provide the evidence. As an example of a city of Bern, we showed a representation of high profiles, which are based on their primary 3 filters. So it's used for routes extension, route change, and planning of new routes. So data including of geographical zones, existing routes, models plate, evaluation profiles, and other basic parameters which we could retrieve from statistical data or GIS data. So and this leads to more detailed configuration and to more precise planning procedures. So mobility needs can be evaluated in a more differentiated way, more time-scaled way, and therefore the bad planning as well as bad investments can be avoided. During this work, we came up with a diagram, with a way to represent the quality of a city, which is kind of assume based on noise factors, CO2, and other indexes which I use it in urban design, but which came actually from the mobility side. So this diagram shows the urban polities along one bus line. So the second type of data is building data. So through the increasingly growing amount of building management systems, we have a kind of access to information of buildings. And that operational data allow us to look on demands and dynamics of energy supply and mobility ecosystems, which we can then upscale to the entire city level. This is also an example of Bern, where we have the data and specific maps partnering, so link it on the energy demand and mobility supply. And therefore, we can provide an evidence and estimate synergies between spatial use and mobility demand, basically, which are based on the data. The third type of data is occupational data. Why and where humans move in the cities or around Switzerland, as you can see on this map, which provides point of interest retrieved from OpenStreetMaps. So we are doing that to estimate, based on also on our other data, how far we move in the cities and how our cities influenced by this movement and the distribution of these cities. So as a part of this third type of data, we work with the open source tools and modeling environment, mostly based on Python, so which are programmed with Python. So we're developing these tools on our GIS level with this additional information in order to simulate how people basically could move in a city, or the evidence how they do move, to provide also an additional level of optimization algorithm to put there an evidence of how we can be more efficient if we change another parameter of our in our geospatial data. This is also an example of city of Bern. An equation is what is share of mobility demands we can bring to the context of functional distribution as usage in space and urban density. So how dense we can build a city to keep certain share of sustainable mobility. And handling these types of data allow us to build scenarios, where each scenario represents a trajectory of a potential development on both categorization of the mobility consumed and urban planning. Basically, both of these scenarios are just a ground of a discussion for stakeholders, which can be used to simulate the human behavior and the urban behavior in just different contexts as it exists now. And of course, it's important to do research, but it's also very important to educate the next generation of urban planners and decision makers with this kind of holistic thinking. And this is example of a course we are running in Burgdorf. We were running in Burgdorf, and students were approached to design, to use these tools to design physical presentation tools. So how you can combine a physical model, which are used often by architects, with additional level of BMIP information on that, and basically to show in this context in an augmented way how this design could work. In concluding, I could say that we need to reintroduce this knowledge on a more larger scale. So if we took this implication, these open spaces in our vehicle systems, so we need to harvest more data, which are actually increasingly available for now, and to make a kind of mechanism which could retrieve all information from this data and provide additional evidence. Thank you.
Thank you, Dimitri, for this very interesting insight into what the Density platform does. And I would like to take questions from the audience that is here first, if there are any, and then move on to the virtual questions. Are there any questions? Amin?
Sure, yeah. Thank you very much for your nice presentation. I have actually two questions. The first is a general question about the whole project. You mentioned, for instance, in the last slides, when you explained the courses that you're organizing, that students, for instance, look at the physical infrastructure, they try to build the physical network, and then by using data, they can see how this system works. But the question is that what kind of research question they are trying to address by using this infrastructure and the data that they have. And for me, it was also a bit unclear in the whole presentation that what are the specific type of questions that, or the problems that these tools can address, or you are currently working on that. And then I go to the second question.
Thank you for asking. Basically, in the course, the main input to the students and the main aim of education to provide a new level of communication methods. So they're using this existing algorithm, but in new way in this urban context. And their model, which is like the urban model, you can see in the newspapers, so becoming much more, becoming a tool actually by this interactive level of augmented reality. So you're not just using the model of to providing evidence what is built, then you interactively can use that to show some changes on the entire city planning level. So you can provide an evidence if you put more cars there, what will happen with the traffic? If you remove cars from the streets, what will happen with the city? So this is more, so we're educating students to use the algorithm in a way to communicate to these official stakeholders, because these people, it's not PhDs, they are, so we are at the Applied Science University, and they will be, tomorrow they will leave university, our university, and we go to the practice. And basically they will bring this knowledge of this communication and of this evidence that if you're using data, so you can design just differently. And this is actually main agenda, how we could bring this communication level, what I was showing in the beginning, how we can bring this missing line, which is short service line, how we can bring these two systems together the mobility planning system and the urban planners. And this is the main agenda of that. So if we use data and algorithm and how we combine those two things together, this is the next level of this urban, of this design, of this designing how we can design a sustainable city of tomorrow.
Thank you. And since my next question was exactly about this slide number 6. So what does it mean, for instance, to combine air transport as a mobility system with urban space at the room level or facade level?
So these people who are living around airport basically are affected by the noise and by CO2, carbon dioxide. And basically, if we build a building in the near of airport, we need to provide kind of a level of security for those people. Then they will breathe the fresh air, and their facades would be not affected from the vibrations and the noise implications of air traffic.
Thank you.
Are there any more questions from the audience?
Yeah, I would have a question for you too. Concerning the last years of the project, what would you say is the main output, main result that you created with this project?
So the main evidence to us is if we use different time scale in designing. So if you put, so if you have two kinds of data, the data of a building, which is solid, which are built, and the data of a traffic, which are in continuous change, we can't build something on in a traditional way on these two source of data. So we need to find a new methods to correlate both of them, to bring them on the same time scale. And the second is that we can actually live much more sustainable. And so by putting, for example, this is a kind of evidence which is built on just few numbers, but we can reduce dramatically the CO2 level in our cities by using electro transport and to use like mobility in a more efficient way by building and redesigning the cities of so point of interest or the special constraints. So and all these things, the mobility and urban space are holding together in to achieve this aim of reducing carbon dioxide.
Thank you.
So if there aren't any more questions from the audience here, then there are some questions that are posed by the audience that is streaming in the chat. And the first one is, what exactly do you plan to optimize? Is it about traffic flow optimization?
So it starts with the traffic flow optimization, but it goes also to the urban design context. So how dense we could build a city to bring this evidence in CO2 reduction. So that these two things are holding one-on-one very closely, much more close as we are considering right now. And basically, if we put more data in our designs, then we will be able to reach this efficient level of urban planning.
And along those same lines that you're looking at traffic flow and also densification, so do you distinguish between different agents in the model? And if yes, which agents?
So we are not far yet. So this is a part of research which is provided by ETH Zurich, so an Institute of Environmental Engineering. Basically, this is the next step, which is dependent on the third type of data. Yeah.
Okay, and one more question that just came in is, you mentioned that you look into the reasons why people move, and do you also look into behavioral aspects, why people choose a certain mode of transportation?
So this is so we base this on the two factors: an economical factor. So they move because they have to satisfy some needs, and the time factor, how fast they could move from A to B, and what are the transaction costs between A and B, and how are they efficient these two factors are holding together.
So that means you do not look into the choice of the mode in the end. You don't specify it down to taking the bus, riding the bike.
Right. If you, this is holding with their urban qualities actually, but on the individual level. So if you take a crowd will statistically behave differently as an individual, but they have same reasons. So, and we're bending on the kind of like on this efficiency and transaction costs, how efficient you could move in the city. So this is basically the most criteria why people choose one kind of transport instead of another one.
Mm-hmm. Okay, I'm not sure if that answered the question, but I guess if the person in the chat could maybe indicate if yes or no. Yes, he says thank you. Okay. Maybe just one last question that is on my mind before we close the seminar is that, so the e-MIP platform is kind of a virtual tool to be used by different stakeholders, and who's your audience, who's your target group that will actually apply this platform?
As I said in the lecture, it's basically it was we've been approached by HESS are bus manufacturer, and it was also founded by Innosuisse. This is an additional Innosuisse project, and HESS is using this tool to provide an evidence to the stakeholders, urban planners and mobility planners of the cities, to show the evidence how they could use this tool and use buses to reduce the carbon dioxide level and increase urban qualities.
Mm-hmm. So actually the audience is just
HESS in
a first step.
And the stakeholders. So they talk basically to officials, and they providing an evidence of the CO2 reduction and urban qualities.
Mm-hmm. Okay, thank you. Are there any more questions? Otherwise, I think we nicely managed to keep it within half an hour. I want to thank everybody for attending, and also the audience that is streaming live, and would like to remind everybody that this video will be available for you viewing afterwards. I will send around a link. And also I would like to announce the next seminar that will take place on the 15th of October. 15th of November, sorry. It will be Viola Papetti talking about different new materials for automotive catalysts, and she will be presenting at the same time. Thank you very much, and I look forward to your presentation, to your participation next time.
Thank you.